Well, this is the last lecture of the course because the next two meetings, nominally I'll be at Los Alamos giving a talk at a symposium there. This talk is you and your research. I've given it many times. It might as well be called you and your engineering career or even you and your career. In the discussions afterwards for this talk, many times discussions have led that these are broad principles of success in many fields. So while I will talk about research, because that's what I've studied, it's really fairly broadly based. Now, I've told you earlier about my career, but I'll remind you. At Los Alamos, I became aware that I was a janitor of science. Some of the people who keep the thing going, but whose opinion is not matter a great deal. They could trust me to do simple things, but the major decisions I was not really involved in. And to put it bluntly and unpleasantly, I was envious, plain envious. And I began to ask myself, what's the difference between the really capable scientists and myself? And I studied it. I went up to Bell Labs, I studied it further. This is really a report on what I found different between the first class and the second class. I want to remind you of something which is not in the notes, what is called the Matthew effect, named after St. Matthew. There's a verse there in the Bible which says, "Unto those who have shall be given, and those who have not shall be taken away." Or put it bluntly, those what got gets and those what haven't got it, you know what happens. It's true in science. When you become famous, it's easy to remain famous. For example, once I became moderately famous, I was invited to give talks at IBM and so on. And when I went there, they would show me this or that that's going on, show me the research labs or production lines and so on. So I got to know more information than the other person. Once famous, it's very easy to remain famous. Once not famous, and what you do will be taken away from you. So it's necessary to do something outstanding. Otherwise, what you do is sort of taken away from you, as St. Matthew said. Now, why do I believe it's important to talk? Because, as far as I know and as far as you know, you have one life to lead. You might as well lead a life you would like to have. And I suggest you a life of doing something significant. By your definition of significant, is worthwhile. To live a life which you got by in the back and you say, well, I didn't do any harm, is not terribly satisfactory. So I am really trying to get you to think about doing significant things by your definition of significant. Now I have to talk about my own experience I have throughout the course, because if I talk about other people's, it doesn't have the effect. My purpose is to stick a knife in your back and give it a good twist and make you say at the back end, well, if Hamming could do it, why couldn't I? After all, he's not that much better than I am. It's doubtful if he is better than you are. So my purpose in telling direct stories is to make you conscious that you can be at least as great or better than I was. And I didn't do badly. Now I'll start psychologically rather than logically. The first objection people have is, well, fame is a matter of luck. I have cited regularly Pasteur's remark, luck favors the prepared mind. Yes, there is an element of luck. No, there isn't. For example, when I met Feynman, he was running computing, and I was brought in to help get him out so he'd go back to physics. I knew he'd get a Nobel Prize for something. He was one of those people. You could see the man had energy and ability, and he was going to do something. It was in the nature of him to be something. Well, yes, luck favors prepared mind, but also it says you prepare yourself and then luck hits you. But there's lots of ways luck can hit you. For example, when I went to Bell Laboratories, the first months I was there, Shannon, a lady, Miss Sally Mead, and myself shared a very big room in the attic. Shannon went on to create information theory. I created coding theory. There were a large number of people around. Yes, it was in the air, but why did we do it? Why was it us? Shannon had done other good things before then. He, in his master's thesis, had observed that Boolean algebra is what you need for switching circuits. He had made a number of very significant contributions. Einstein is famous for writing 5 papers in 1 year in a journal, several of which are very great classics. It isn't luck. It is two. I gotta say both it is and it is not. You prepare yourself by the way you lead from day to day, lead your life from day to day. You prepare yourself for success or you don't. And when the lightning strikes, you're either ready or you're not. It misses you or it hits you. What will be is open to debate, but I think that Shannon, if had not created information theory, would have done other significant things. He'd done a bunch before, he would do ones afterwards. So I sort of deny it. At least I deny it's all luck. Now, Newton observed, Sir Isaac Newton, that if other people thought as hard as he did, they would get the same results. And Edison said genius is 99% perspiration and 1% inspiration. And I tell you the same thing. To a great extent, it is constant hard work that does it. Nothing more and nothing less. The very able people work very hard all the time. At Los Alamos on Sundays when we goofed off a little bit, when we went out hiking in the mountains behind Los Alamos, they still talk shop. They were at the problem all the time. Now, one of the characteristics, but not always, is that when young, they showed a great deal of ability. Newton did not. As far as I can make out reading biographies, he really didn't look unusual to anybody until after he came up to Cambridge in college. And his mathematical knowledge was about arithmetic when he came. He's an exception. And there are a few others. Now, Einstein, consider the fact that after he got his doctorate degree, he had no legitimate job except for 7 years in the patent office. No job at a university. He didn't get early recognition. But when he got it, he did it. And that indicates that the IQs and such other things which people are supposed to have, it's a help, but quite a few great people don't have fabulously high IQs as measured by the normal methods. Einstein certainly did not look like a good student. Great many other people didn't. A personal example, he's dead now, so I can tell you. A guy named Bill Fan walked into my office at Bell Labs, and he wanted to do zone melting. Now, zone melting, you have a bar, you have a coil around it which you heat by induction to melt the metal, and you move it down slowly. If the impurities stay in solution, you drag the impurities down. If the impurities are trying to drop out, they're pushed to the other side. And many, many passes removes the impurities from the middle of the bar. Well, he had some equations. I put some algebra on it and some calculus and got some partial answers, but I could see that he needed computing. Well, I went around to his department and asked about him. Well, they didn't think much of him. I go back to my office. I thought he had a good idea. I had resolved to work with important people. I wanted to do important work with important people. Here was my chance to contribute to a really good idea if it were good. But his department didn't think much of him. But I reflected. Muhammad had to leave town, flee for his life. A prophet is without honor in his own country, remember? It will be often true that your local people cannot see that you are doing great work. I concluded I would help him. I taught him how to use the machine. I made machine time available to him and so on. And well, he picked up all kinds of prizes. He became a famous man. His laboratory was made a national treasure one time. Also along the way, from being inarticulate and knowing little mathematics and lacking confidence, he became a man who spoke clearly and well and gained confidence. He had lacked confidence when he was young, and that success, zone melting, was his one great idea, but it was what Bell Labs needed and what everybody else needed. We needed to be able to make germanium without very many impurities. Then we needed to be able to put as many we want in, because if you now take the same zone and drag it down, you can drag down impurities about the density you want in them. You have remarkable control with zone melting. Now you make 1,000 passes or something, and that's why you can't do it numerically. other than with a computing machine, because the 1,000 passes have end effects and they bounce around. So I was right that time. I guessed that the man had something important. I worked with him, and I was part of something that was important. Now, having disposed of psychological objections of luck and lack of high IQ, because some of you say, well, I wasn't the brightest student in my class, so what? It doesn't matter. Let's get down to other things. Now, the most important thing, probably, of great people is they believe they can do great work. They have confidence in themselves. If you don't think you do great work, it's not likely that you're ever going to do it. It's that simple. Now, you can be too overconfident, but you should have a fair amount of confidence. Take, for example, Shannon. You remember when I did information theory, I pointed out how, when stuck with random codes, he averaged over all random codes and showed the average was arbitrarily good, therefore one good code had to exist? Who but a man with almost infinite courage would do that? He had it. Now, I can tell you another way, simply. There was a year or so when he came in about 10 o'clock, played chess till about 2 and went home. At the end of the year, the company gave him a salary raise. But all you could see him doing was that. But at home, he was creating information theory. Well, the way he played chess is the following. When you are attacked in chess, you can either defend yourself or you can attack back. Shannon never defended himself. He attacked back. And the game would get tied up more and more and more and more complex, and finally he'd stop and think for a long while, grab his queen, advance it, and say, I ain't scared of nothing. Bingo. The whole game would collapse then because he finally precipitated all the pending operations and he either won or lost. Well, I learned that expression, I ain't scared of nothing. I've used it several times on myself. When stuck and I didn't know what on earth to do, I said, good enough for Shen, good enough for Hamming. I ain't scared of nothing. Let's go ahead and see what happens. And sometimes, by copying his style, I came through to success. I deliberately copied his style. Now, another example. I hope most people are dead. I guess they aren't, but they won't hear this. I was in the math department, and the math department, we used to go to lunch together. They played games, threw boomerangs, flew kites, and played this and that. And they fiddled around. And I wanted to succeed, and I said, I can't afford to waste lunch times. So I went around to the physics table where I'd written a paper with one of the physicists, a good one. And I said, may I join you? Sure, I'm welcome. The table consists, among other people, of Bardeen, Shockley, and Bratton, the Nobel Prize winners, J.B. Johnson of Johnson Noyes, and some others, my friend, among others. And I used to have lunch with them for years. I learned a lot. I learned a lot of tricks out of Shockley, how he did things. I watched other people. I learned how to do things sensibly. Well, finally, the Nobel Prize came through, promotion came through, jobs elsewhere came through, and all the able people left, including my friend. He was promoted up the line. Well, what was left was the dregs. Hardly worth eating lunch with. But over in the other corner of the dining room was a big table, the chemists. And I had written a paper on nuclear magnetic resonance with one of the guys. And so I said, do you mind if I join you? So I sit down and we start talking about chemistry and such other things for a long while. And finally, one day, I walk in and say, if what you're working on is not important, and it's not likely to lead to important things, why are you working on it? After that, I ate with the engineers. That was spring. In the fall, going down the long corridor, Bell Labs, my friend chemist stopped me and said, you know, Hamming, that remark of yours got underneath my skin. I've spent the summer thinking about the important problems of my field. I have not changed my research, but I think it was well worth the time. I say, thank you, Dave, and walk on. About 2 weeks later, I noticed he's made head of the department. About 10 or 12 years ago, I noticed he is a member of the National Academy of Engineering. I have never heard of anything about any other person at that chemistry table. Not one. The one man who could hear, if what you're doing is not important, not likely important, why are you doing it? The one man who did become important. He did succeed. The rest of them who couldn't hear didn't. It's that simple. If you don't work on important problems, you are not going to do important things except by the dumbest of dumb luck. You must work on important problems. Now, you can't work on them all the time because that's what Nobel Prize winners do. They get a Nobel Prize and then they think, like Shannon also, they can only work on important problems. As a result, they don't do anything. You have to plant little acorns which grow into mighty oak trees. But you have to plant the acorns which will grow. You have to learn the small things. So the great thing wrong with Nobel Prizes is you now think you can only work on important problems. And you don't. What you have to work on problems which can become important and matter, which have a future, which will grow into mighty oak trees. Another thing that ruins Nobel Prize winners, of course, is everybody gets famous. You are put in all kinds of committees and all kinds of other things, and you can't get any work done. They stop you from doing it by various promotions and so on. So that's a lot of reasons why Nobel Prize winners often don't do very much afterwards. Now, confidence in yourself, I said, is important. Overconfidence, of course, is a disaster. I'll put it as I did the other day. The difference between being strong-willed and stubborn. The difference between confidence and overconfidence is about the same thing. It's this fine line. I've seen a lot of people abandon a good idea too soon, and I've seen people cling to a bad idea too long. They're both difficult problems. Now, one of the features which you can cling to regularly is a desire to do excellent work. Whatever you do, you're going to do well. Now, it's not true what my father said. Anything worth doing at all is worth doing well. There are some things you might as well get rid of. Like you have to sign some paper for this or that. You just sign them. You don't try and write your handwriting the most beautiful one you can. You just get rid of it. But in general, you try and do excellence. This is the one guide I think you can say, whatever I do, I am going to do well. And that will give you some unity. Because I've talked to you before about the drunken sailor who staggers a couple steps this way, then a couple this way, then a couple this way. In a total of many, many steps, he gets a distance to the square root of n. But if there's a pretty girl over there, he staggers like this, and he staggers like this, and he gets a distance proportional to n. When you have a vision, you will go a long way. Without a vision of what you're going to do and where you're going to be, you're not going to get very far. It's that simple. You have to get a vision of what you are going to do and be, and then pursue it. And excellence is one of the best tracks you could use. I am going to do things very well. I'm going to do more than just a good job. I'm going to do a first-class job. Now, what you may consider good working conditions may not be for you. It's very sad, but what you think are good working conditions are not. The example I've given you already is working with the door closed or open. If you work with your door closed, you won't be interrupted, you get your work done. You work with your door open, people come by and stop and chat and so on and so on. But I've noticed very clearly at Bell Laboratories, those who work with the door shut may be working just as hard 10 years later, but they don't know what to work on. They are not connected with reality. Those who had the door open may very well know what's important. Now, I cannot prove to you whether the open door causes the open mind or whether the open mind causes the open door. I suspect of both. I can only establish the correlation, and it was quite spectacular. Almost always. The guy with the door closed were often very well able, very gifted, but they seem to work always on slightly the wrong problem. So you have to get wide feeling for what is going on. And the supreme example of this closure is the Institute for Advanced Study at Princeton. They take in people who've done something great. They give them luxury, a beautiful office, a beautiful restaurant to dine in, wonderful grounds and everything else like that, adequate salary to live on, no cares, no worries, no nothing. You're freed for life on anything at all. What happens? The bulk of them continue working on the problem that made them famous. They keep on elaborating and so on. Well, they've already made it famous. It doesn't have to be added to. They got the thing going. Rarely do they change. Now, von Neumann was a person different. He was the Institute, and he did go out in reality and turn up in Washington and other places. He traveled widely and was receptive to new ideas. But the bulk of the people who got appointed to the Institute for Advanced Study don't keep the door open on life, as it were, and they don't do anything comparable to what they'd done before. They're very able people, but the Institute, in my opinion, sterilized them to a great extent. So what do you think is the ideal working conditions or not? Now, I'll give you some examples of this. When we began with the IBM 701 computer, we programmed in absolute binary. And there were a bunch of these machines in the West Coast airframe companies, and the rest were scattered around. Now, it became obvious to me that the method the West Coast used for programming, namely, we hire an acre of girls spread out, and they program. Typically girls, but sometimes men, but mainly they were programming girls in those days. Well, it was clear to me Bell Labs would never give me an acre of girls. They weren't about to do that kind of a thing. Well, what do? I'm in computing, I want to be in the frontier. What everybody else has, I'm not going to have. Well, I could quit and get a job on the West Coast. Probably any one of the number of airframe companies, because I was reasonably known out there. But Bell Labs had a lot of very good people, and the airframe companies have a few good people scattered widely, but not a high density. Remember, I'm about trying to learn how to be great, so I'm studying great people. Bell Labs is a place to study, but the airframe is a place where to get a tool. So I think for a long while, and one day I said to myself, Hamming, you believe a machine can do anything. Why don't you make the machine do the programming? Well, what was the cause? The net effect was that I was put immediately right in the frontier of programming. How do I make the machine do the programming for us? What appeared to be a defect, by turning the problem around, became an asset. Grace Hopper has told several other stories a similar way. What appears to be a defect is an asset. So frequently, when you think things are wrong and you haven't got the wherewithal to do it, if you turn the problem around, you can turn it into great success. Another one is slightly different. When I was doing this 28th order system equation I told you about, a Navy intercept plane, I was solving it on a digital machine because the analog machine outside of Philadelphia couldn't do the job. No analog machine at that day could do it because they didn't have the required accuracy. Well, I was using a variation of Mills' method, which was pretty crummy. I had found Mills' method was unstable. I'd patched up a little bit. There it was. One day, I realized the following. I was going to have to fill in a report of what I did because government contracts always require reports. And everybody who had an analog computer was going to try and pick flaws in what I did because I was really showing that a digital machine could beat the analog on its own home ground. That's really what I was doing, not getting the answer to the problem. I was really demonstrating something much more important. Well, I promptly started deriving a better method of integrating the differential equations. And I finally used a method which is for some years was known as Hamming's method. I don't recommend it now, but it was very suitable for the machines as they were. And so I had the girl programmer change a few of the instructions, run a trajectory once more to check the new program got the same as the old answers, and then went ahead. Thus, the report has a very jazzy method of solving differential equations instead of a very crummy method. Both were equally effective, but one was defensible and one was not. You see, I changed the nature of the problem. I saw that the problem, although originally was get the answers to these trajectories, in fact, it was something else. It was proving that a digital machine could beat the analog machine on its own home ground of differential equations. I redefined the problem and made it a success. I would not have found Hamming's method if I had not realized that the method I was using, which was adequate for me, and we could all see we were getting the right answer, but it was not nice, it was not clean and simple, it was rather ugly. So I changed the problem. Now these will all tell you the conditions you want are seldom realized, but that you can change the conditions that you have to make success, either by inverting the problem or, as I told you the second story, changing the nature of the problem and recognizing the underlying real problem. Now that's something I've done several times. There's one very early problem I solved, spectacularly successful, not only on a computing point of view, but from a physics point of view. The value in the transistor research was extremely valuable. Well, I meditated over why was that successful. I studied it over and over again. And I believe this statement, you should study your successes. You don't study your failures, study successes. Because when your time comes, you'll know how to succeed. If you study failures, you'll know how to fail. So study success very closely, not only yours, but other people's. Why did Galileo do what he did? How did Newton do it? Try as best you can to study other people, how they succeeded, what were the elements of their success, which elements of that can you adapt to your personality. You can't be everybody, but you have to find your own method. And studying success is a very good way of forming your own style. Now, one day, I think I've told you a story before, I'll repeat it. One day I found John Tukey, with whom I was working extensively. He was my age, and the guy was clearly a genius. I went into our mutual boss and says, Hendrik, how can anybody my age know so much as John Tukey does? Well, he leaned back in his chair, grinned at me, and said, Hamming, you'd be surprised how much you'd know if you worked as hard as he did. I slunk out of the office. There wasn't anything to say. And I stayed home. When I was home, I thought frequently, I'm not working really as hard as I could. I'd never be able to work as hard as John does. I haven't got the psychic energy, but I can work a hell of a lot harder than I have been. Let me reorganize my life. Let me quit spending my time in reading nonsense magazines and thumbing through the newspaper. They're not very important to my career. Let's spend my time studying things in my career. For example, I got appointed deliberately a book review editor. Therefore, there's always a book on my coffee table right next to it waiting to be read and a review written. When a review is written by me, I set it aside for a week and ask myself afterwards, is that a good review? Does that really digest the book? If it doesn't, you're rereading the book and writing a better review. This way I forced myself to get a wide acquaintance in computer science. And being the book review editor, I got to review the books I wanted. This was a device. Now, it's true, I quit reading New Yorker, I quit reading magazines, I quit reading other things. My wife complained occasionally that all I looked at New Yorker was the jokes. She was right. I didn't have time to do everything. I wasn't a first-class genius. I had to work hard. So I simply set aside those other things and did that. It's not hard to do. You just do it. Now, I want to say another couple things. The race is not to the swiftest. The guy who works hardest doesn't win. The person who works on the right problem at the right time in the right way is what counts and nothing else. And that's what I'm trying to do in this whole course. I've been trying to teach you something about style and taste, so you'll be able to have some hunch of when the problem is ripe, what problem is ripe, and how to go about it. The right problem at the right time in the right way counts, and nothing else counts. Nothing. You've got to do that. But it's easy. There's a million races being run. You just got to get in one of them and win. Now, I mentioned earlier, with regard to the chemists, about what are the important problems in your field. At the urging of some other people, partly, and partly of my own, I used to set aside Friday noon and Friday afternoon for great thoughts. Meaning, yes, I'll answer a telephone, yes, I'll sign a sheet of paper, but mainly, what is the effect of computing on science? What the hell am I doing with this computing machine? How is it going to affect AT&T? What should I be doing with computing? What is the nature of software? My friends all after a while got to know. Friday afternoons, great thoughts. What's the nature of this, that, and the other thing? I spent 10% of my time trying to answer the question, what are the important problems in my field? 10%. Friday afternoon, straight through. Don't do it Monday morning because you'll be interrupted immediately. If you do it Friday afternoon, some of it can linger over on to Saturday and Sunday. If you do it Monday morning, there's a hot conference at 10 o'clock and bingo, everything's broken up. I use it Friday afternoon for many, many years. I recommend that you find a regular time to stop and think. What are the important things? What is going on? What is the nature of what you are doing? What is the characteristic of the job? What are the fundamentals behind it? So you'll have some idea of where you're headed so you can march in a uniform direction and get far rather than being a drunken sailor and getting nowhere. And I've regularly in this picture tried to stress, in these lectures, stress the bigger picture. I've tried to stress fundamentals. No one knows what the fundamentals will be tomorrow, but you can try to ask what are the fundamentals, the things upon which other things seem to depend, and those things which seem to be true tomorrow, but maybe not. I've also stressed the necessity of learning new things. All kinds of new fields come up endlessly. They're going to keep on coming up. You have to get some grip on them. You can't learn them all, but you have to get an idea. Well, that is relevant to my field. That's interesting, but it isn't relevant. Forget it. It's a very difficult problem to do. Now, there's another thing I have to talk about: great people. It took me a long, long while to discover this. After I've been studying, I'd say 15 or 20 years before I realized the tolerance of ambiguity. They both believe and disbelieve. Now, most people want to believe something is true or it isn't true. Great scientists believe the theory is true enough so they continue working. Because if you don't believe the theory is true, you won't. But they disbelieve enough to notice what's wrong and make the big change to the new theory. If you believe the theory is right, you won't make the big change to the next new theory. You won't make the big step forward. You'll merely elaborate and extend the old theory. And that won't make you a great scientist. It'll make you just a good one, which I'm not complaining about, but greatness consists of seeing what other people have missed and seizing upon the contradictions and making the new step forward. You have to tolerate ambiguity. And I have not the faintest idea how I'd ever teach a course in ambiguity. I've thought about it many times. How would I put a course together to teach students to tolerate ambiguity? I haven't a clue. So I don't know what to do. I merely tell you that the tolerance of ambiguity, not being so certain everything is correct, is a necessary feature. Now, most great scientists have 10 to 20 problems in their minds, ones which are hanging around, which when they get a clue how to attack, they drop other things and rush into that problem and finish it off first. Something between 10 and 20 problems which they think important, but they don't know what to do. Now, let me warn you about important problems. The importance is not the consequences. All the time I was at Bell Labs, no one worked on the three outstanding problems in physics: time travel, teleportation, and anti-gravity. They're not important because you haven't got an attack. The importance of a problem, to a great extent, depends upon have you got a way of attacking the problem. Problems are not important per se, although they have some consequences. The most important thing that makes a problem important is that there is an attack. You have an idea how I can go about that problem. You want to watch it. Just because the economic consequences are great, and take those three of them: anti-gravity, teleportation, or time travel, the economic consequences are unbelievably large. But they're not important problems. You have an idea how to do it. When you have, then they may become important. Now, quite a few times I've been practically saying the following: it is not what you do, it's the way that you do it. It's the style you go about doing things. It's inverting the problem or changing it. In the words of the song, it ain't what you do, it's the way that you do it. It's the style in which you do it that makes the difference. You only look at special relativity. Poincaré had it all. Several other people had it all before, but Einstein did it the right way. And you only remember Einstein as having done special relativity. The other guys had it all. They even gave talks on it. But they had it screwed up to some extent. They didn't have it really clear and straightforward. Now, when you first do a thing, it's often muddled up. And one of your problems is to get it clear so it can be communicated to other people. And you can spend a lot of time lying in bed saying, well, gee, how can I say that to Joe? If I try it this way, Joe might misunderstand that. How about that? How about this? Until you finally have a way of looking at a problem which looks simple, straightforward, and clear, so you can communicate it to others. It may not be the way you found it. It often is not. But getting it clear is important, which brings me to the topic of communication. You need to learn to communicate orally in talks like this, written and written reports, and casual conversations. In the middle of a conference, you have to be able to get up and say, that's wrong for these reasons, bing, 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 and you win. If you sit around and say, well, I'll write a report tomorrow after I've thought about it some more, the decision is made, we go ahead, and it doesn't matter what you do then. The ability to communicate at 3 levels. Now, how do you learn it? You can read books if you want to, but forget it. The way you learn, as far as I'm concerned, is every time you go to a talk, you listen not only to the talk, but to the style it's done. What talks are effective? Why were they effective? What aspects of the speaker can you adapt? For example, if you're going to give after-dinner speeches, generally speaking, there are 3 jokes. One at the beginning, when you get up, one in the middle to keep awake, and one last one so they'll remember something that you said. Well, I had to learn jokes. I discovered that I cannot tell shaggy dog stories. I can tell one-liners very well, but I couldn't. I had to adapt my joke telling to what I could do. Those who told shaggy dog stories, yeah, very interesting, but I simply cannot do them very well. You have to adapt what you learn from other speakers to you. When you find a person who's very effective doing something, can you do it? Why not? Maybe you can't. Then you have to do something else. But if you yourself will learn to criticize other talks, then you will have a critical basis to criticize your own, and then you'll be able to give good talks. If you can only follow what books say instead of learning your own style of creativity, it isn't going to work. So I think that the best thing you can do is start, as of tomorrow, when you hear lectures and talks, ask yourself every time, besides what was the content, what was the style? What part can I adapt of that technique? Why was that speech effective? Why is that speech not effective? And you can ask your friends to check that your opinions are somewhat the same as theirs, and you may find sometimes they don't agree with you. What's effective talk? It's a bit of a problem there. Now, it's a poor workman who blames his tools. I've always adopted the philosophy, I will do the best I can with what I got. Thus, this school has got a great many faults. The bureaucracy in Washington periodically does strange things, other things. The students have peculiar features, they have to disappear now and then. Well, you don't blame the system. You do at each course and each lecture the best you can given the circumstances. This course has suffered from the fact it's being broadcast, so you've all been intimidated and afraid to just raise your hand and say, Hamming, I think you're crazy. What about such and such? The fault of this course with the television on is that you people have been too intimidated. Well, I'll do the best I can. I knew perfectly well I couldn't get you to interact very actively in a class, so I gave up on that one, though I did get you 1 class lecture. Now, there's another thing you have to recognize. If you're going to have progress, there has to be change. Change does not mean progress, but progress requires change. Most people and most institutions don't like change. They resent it. And therefore, in order to make progress, you have to sort of welcome change. You have to embrace it in spite of the fact you don't like it. Why, we've always been doing this way, perfectly all right now, why should I ever change? You can adopt the model I did. If the department has been doing this for 10 years, the same way, it's time you should change to find out how to do it some other way. I know it's perfectly satisfactory, forget it, there might be better methods. You'll never find out if you stay in the same damn rut. Needless to say, most departments of Bell Labs didn't like my motto. But that was my motto all the time. If you've been doing the same thing for a long while, why is there no other method of doing it better? You will never find other methods if you don't try other things. Some other ones will make them worse occasionally. But without change, you will not have progress. Now, when you're learning things, I told you, you need to put hooks on ideas so they can be covered widely. That was the thing that John Tukey could do and I couldn't for so long. He could dredge up almost any kind of information. After he told me, I could see that what he said was true, but I couldn't think of it first. So I started doing what he did. When I got a new piece of information, I turned it around many ways until, as it were, it was connected with many pieces of information so that in various situations that would come available. And it has worked out fairly well. Now you're likely to say to yourself, you haven't got the freedom to work. I didn't either when I began. I had to do more or less what's expected. When you hire a plumber to fix the plumbing, you expect him to be already trained. You expect him to be able. You don't give a person a big, lovely chance to do something great when they've not already demonstrated greatness. The onus is on you to demonstrate greatness, and then you'll get the opportunities. It's not the other way around. And it's beautifully put by an instructor when I was at Nebraska. The instructor went to the head department and said, I want to be relieved of some teaching so I can do some research. The head department said, when you've done the research, I'll relieve you of the teaching. You have to demonstrate your ability first, and then you'll have the freedom to do it. Otherwise, no. I had to do error correcting codes at home on my own time. After I became more able, management left me alone. In fact, at the back end, the management clearly had the belief the more we left Hamming alone, the more he'd worry about what should be done, the more likely he's going to do the right thing. That applied to a guy like Hamming who had a conscience and was worried. It doesn't apply to some people. Some people, you give them freedom, they'll do nothing. But I was compulsive and I was worried about doing the right job, so I did. Now, I have to answer the question, is effort to be a great person worth it? Now, great isn't by definition of what you think is great, not mine. Is it worth it? I will claim yes. I've talked to various people. Now, people who tried to succeed and didn't, I was afraid to ask. But those who did succeed and were famous, I asked them, was the struggle worth it? And they said, yep, it's better than wine, women, and song put together. I didn't ask any women. They might have said better wine, men, and song. I don't know. But they all thought that doing something really first class and knowing you've done it is better than anything else they could think of. I can't give you a report of the guys who didn't do it. As I said, I was afraid to ask them. I didn't want to embarrass them. Well, let me come down now to a saying of Socrates, who lived about 470 to 399 BC in Greece. He said, the unexamined life is not worth living. I heard it when I was first time I heard it when I was crossing the campus at Yale behind a professor and a student. And the professor turned to the student again and said, the unexamined life is not worth living. And before we crossed the whole quad, he had said it 3 times. The unexamined life is not worth living. You should examine your life. You've only got one life to lead, as far as any of us know. Why should it be the life you want to have it, instead of whatever happens to you? To come down the back and say, well, I didn't do any harm, I had an enjoyable life. Is that what you want to say in your old age? You just had a good time in life? Or do you want to say, you know, I did something that was important, at least something that I thought was important? That's your problem, therefore, to pick these things up and do it if you want to have a happy life at the back end. Now, I think all these questions are style. I kept saying several times, you've got to work on the right problem at the right time in the right way. Otherwise, you're doomed. Style is everything, and it's not communicable in words. I cannot tell you what makes a great painting. I can show you once. I can show you success, which I've done in this class. Now, in summary, in a sense, I want to give you a different view of the whole course, particularly this lecture. I'm a revivalist preacher, if you want. I'm saying, repent your idle ways and get down and be somebody worth being. This is what this lecture is all about. Revivalist preacher preaching. Well, now, I've told you things, how to succeed. No one ever told me these things I've been telling you. Nobody. I had to find them for myself. I've told you how to succeed. You have no excuse for not doing better than I did. Thank you.